So we're going to start law of sines today. You will see that you have law of cosines and you have law of sines. Okay, so this entire semester has been built on the idea that we have a right triangle, but what happens if we don't have a right triangle? And no, then we have what we call law of sines and law of cosines. Now, a not right triangle is called an oblique triangle. Okay, so you don't have a right triangle. And the law of sines is pretty basic. Okay, you see the very top of your formula sheet. It's just ratios. So the law of sines is if you have a triangle ABC with sides A, B, and C. Now notice the sides are lowercase, A, B, and C. The angles are considered to be uppercase. So here, down here, we have A, B, and C. And then side A, now when we look at the side, it's exactly opposite from the angles. So this would be side A. Side B then would be opposite the angle, and side C would be opposite the angle. Now you have one or two things. You can have an acute triangle, such as we have here, or you could have an obtuse, which means that it's bigger than 90 degrees. And so then side A is across from it. We've got angle B, side B is across from it, angle C, and side C is across from it. Okay? And the law of sines is all you're doing is you're picking two sides and corresponding angles, and you're making up a proportion out of them. So if you have side A and side B and angle A, then you could find angle B by using this proportion right here. Or maybe it's B and C that you're going to put together. Or maybe it's A and C that you're putting together. Now, some people put the sides on top and then the sign of A on bottom and so on. Some of them switch them and put the sign on top and then the side on bottom. Either way, it doesn't matter. You just have to be consistent, just like a normal proportion. They have to line up to be the same thing across from each other. So here's an example. Okay, we have angle C is 102.3 degrees. So side C is across from it. Angle B is 28.7 degrees, and side B is across from it, which is 27.4. So we don't know angle A, and we don't know side A. Those are the only three things, right? Side A, angle A, and side C. And we're supposed to find the remaining sides in angle. Okay, so it doesn't always have to be the sine, law of sines. It could also be that you know that the angles in a triangle add up to 180 degrees. So if they add up to 180 degrees, we can find side A pretty easily. Absolutely not. We're just going to find it like we normally would. So we have 102.3, we have 28.7. Okay, that gives us a non-decimal. Okay, so that means angle A then, we have to get up to 180, so what, 49 degrees? Yep. So angle A is 49 degrees. So it doesn't mean you always have to use law of sines to do this for everything. Okay, sometimes you don't have to. Now, to find the rest of them, we are going to use the law of sines. So let's start with finding side C. What I'm going to do, if I want to find side C, I have to start with the sine of angle C over side C equals, and then I have to set that up with a proportion of something I know. We know everything about B, right? Angle B is 28.7 degrees. And side B is 27.4. I had no choice but to use this exact information because this is the only set that I knew for sure the whole thing. I knew the angle and I knew the side. To find C, I knew the angle, so then I could set this up. Now it's time to do a proportion. Do you guys have your calculators up? Can you figure out these things for me? Okay. No. So sine of 102 degrees. Can someone find that for me? Okay, so the sine of 102.3 is 0.977 over C equals, and then the sine of 28.7
0.48.
over 27.4. Now we need to cross multiply and divide. And so we get what for C? 26.77. All right, so that's not correct.
Yeah, it's 55.74.
Oh, I don't know. 55.77.
Okay, 55.74.
I got
75.
77.
We put 75.
75?
Yeah.
Okay, now, is that from our calculations, Brooke? You got 77
Yeah.
from our calculations? And are you getting it from your cheat sheet?
Yep.
Okay, so we'll go with 0.77. All right, now, how did I know 26.77 was not the correct side? So what I'm looking at is that,
One's bigger than this.
the angle, the biggest angle should have the biggest side, right? So my biggest angle is 102.3. This side should be bigger than any other side. If this one's 27, I know my answer is not 26, okay? So I'm looking for a number bigger than 27.
Wait, what the 26.77?
I don't know, somebody told me that.
No, I just did the one part. I didn't divide it by one part.
Okay. So, we need to not have this.
Is that supposed to be the 55.77?
Yeah, it's 55.77, so she just hadn't divided by 0.48 yet. Okay, now we still have to find side A. Unfortunately, we can't just, subtract from 180 and have it. So instead, we have to do another setup. Okay. So now we're going to set up to find side A. Okay, now side A, we can still use this side of our proportion, because that's the same. And I already know that that's 0.48 on top and 27.4 on bottom. Okay, so then for side A, I need to use, on top, I'm going to use the sine of A, which is 49 degrees, over A. Okay, so once again, we're going to cross multiply and divide. What is the sine of 49 degrees, by the way? 0.75? Okay, so then we'll cross multiply and then divide by 0.48. And what do we get for A? $43.08. All right. Once again, I'm double checking by looking at my angle compared to other angles and then checking that my sides compare the same way. You got something different?
Yeah, I got 42.81, but I don't know if I did it different.
That's right.
What is?
For the first angle.
43.08, might be
So I did
rounding or something?
0.75 times 27.
I just leave it
Oh,
as sine
you have to
49,
do
so
parentheses,
I got
otherwise it might divide first instead of.
I did that last time though when it was very intensive.
This is the whole number. That's
She used the whole number. I used the rounding.
You shouldn't. You shouldn't round until the very, very
You
end.
shouldn't use that rounding number.
Okay.
Oh, because then the first
So
one
mine
would have
was
been
that
wrong
first?
too then.
Okay,
Because I used the.
okay. So, let's all look at page 267 in your books. Okay, so it tells us a little story on the page, right? We've got a pole that tilts towards the sun at an 8-degree angle. Where's that angle? What does their drawing show it at?
It's like off the triangle.
So if this is an imaginary vertical line, they're saying right here is 8 degrees, right? Is that what they're saying? No? I think that's what it says.
Yeah.
Okay.
Yeah. It's just like.
Okay. And so, what's the question it's asking? It's going to give a shadow.
how tall is the pole?
Okay, it's going to give a shadow. It's asking how tall is the pole. Okay. Does it give us any other information?
22 feet.
What
on the
is?
bottom.
What is that?
C.
It casts a 22-foot shadow. Okay, so the shadow is 22 feet. All right, I can make a triangle here, can't I?
43 degrees right there.
Where?
In the right corner.
Why does it say that? Does it say that in the problem?
Yep.
Okay, it says that for right here, this is a 43-degree angle. Okay, so really, we're ready to go, aren't we? Are we? What's this angle really? This whole angle? The whole thing?
90.
It's 90 plus 8, so it's 98 degrees. Because the reason I ask that is if I'm going to use this as a side, I definitely need to have that angle there. And in order to get that angle, I need my other two, so they add up to 180. Okay, so let's see here. Do they add up to 180?
It's just at 8 degrees.
So 98 and 43, if I add those together, what do I get? No, 141. Okay, so 141. So then what is this angle right here? Yep, 39. All right, so 39 degrees up there. All right, so we take 141 away from 180. And so now I have to set this up. Some things that I have, my proportion, the part of my proportion that is complete are those two. So I've got the sine of 39 degrees over 22. And I'm trying to find x, so that'll go on the bottom. And on the other, the angle that goes with that is my 43 degrees, so sine of 43 degrees. So now it's a matter of cross multiply and divide, and if you do that correctly, it's just a matter of being able to use your calculator correctly, you should get 23.84 feet.
So when we type it in, we should just leave it as the